Lesson 17.4, Task 3. Factor perfect square trinomials. Example 3, factor 12x cubed minus 84x squared plus 147x completely. Again, look for a greatest common factor and factor it out before looking for a factoring pattern. Anytime I see numbers this large, I'm going to think there's probably a greatest common factor. Also, if I've got x cubed, x squared, and x, I know all of these have at least an x in common as well. So, what number could I look for to use that as a greatest common factor? We'll start with your factors of 12. Does 12 go into each term evenly? No. So then what are other factors of 12? So you got 1 and 12, 2 and 6, 3 and 4. So you're going to check those to see what number goes evenly into each term. All right, so if you look, 3 goes into each of these evenly. So 3x would be my greatest common factor. All right, if I factor 3x out of the expression given, 3x times 4x squared minus 28x plus 49 is what I have left. All right, so if you multiply this together, distributive property, 3x times 4x squared is 12x cubed. 3x times negative 28x is negative 84x squared. And 3x times 49 is 147x. So again, these two things are equivalent. So far, all we've done is factor out the greatest common factor. Now, if you recognize this form, you know that it's a perfect square trinomial. So this is a perfect square, and this is a perfect square. So if I take 2x and 7, that gives me 14x, and then times 2, because my middle one is always twice that, that's going to give me my 28. So it does fit this pattern. So it's good to have good number sense, and you can recognize numbers and know perfect squares and things of that nature is going to be much easier to do these if you recognize your perfect squares and know all of your multiplication tables very well. And again, that's something always you can practice. If you've got dependent upon a calculator, just do some practice skills where you just try to re-memorize some of your multiplication tables and look at perfect square tables, and that way it'll help you remember your perfect squares better. All right, so factor the trinomial. So we can go from 4x squared minus 28x plus 49 to 2x minus 7 times 2x minus 7. Again, the negative in the middle tells us that this binomial is negative. And when we have the same binomial twice, we can rewrite it as a binomial squared. So we still have the greatest common factor. Like if we just had the binomial squared, that would only be equal to what's in parentheses here. If we want it to equal what we started with, we also have to multiply it back by the 3x. So when it's completely factored, it's 3x times 2x minus 7 quantity squared. So it says, why is x included in the greatest common factor? X is always a part of the greatest common factor? No, it's only a factor if it's common for each term. And in this case, it did have an x for each term. If you remember, we started with x cubed. X times x times x is x cubed. So we do have an x in each term to begin with. All right, that's all for task 3. If you have questions, let me know. Lesson 17.4, task 4. Solve quadratic equations using special factoring patterns. If ax squared plus bx plus c is a difference of squares or a perfect square trinomial, then equations in the form ax squared plus bx plus c equals 0 can be solved using the zero product property. All right, the volume of a fish tank pictured is 9 cubic feet. What are its dimensions? All right, so you can see that it's saying this is distance of x, this one is a distance of 4 feet, and this one is a distance of x as well. So you can use a factoring pattern and the zero product property to find the dimensions. Write a quadratic equation for the volume. So length times width times height or some version of that equals 9. So you always have, here's height and length and width, multiply those three sides together, and that gives you the volume of your fish tank, as long as it's a rectangular shaped object there. All right, so write a quadratic equation. 4 times x equals 9. So 4x squared. Same base, you add exponents. When there's no exponents, you assume it to be a 1. So 4x squared equals 9, and then we can subtract 9 and set it equal to 0. That's how we would use the zero product property. So it says in this equation, 4 times x equals 9. Blank represents the width. I guess we're going to go with 4. And blank represents the length, so x. And blank represents the height, another x here. All right, so we've got width times length times height, and that represents the volume of the fish tank, which is 9. All right, so it says solve the equation for x. All right, we've got 4x squared equals 9. Subtract 9 from both sides, so now it's equal to 0. 4 and 9 are both perfect squares, so hopefully you recognize. Back from task 1, this is a difference of perfect squares. So 2x plus 3 times 2x minus 3 equals 0. Set each factor equal to 0 and solve using the zero product property. So it says a correct step that could have been inserted in the equation is... All right, so before going from this step to this step, if you wanted an extra step, you could show that 2x quantity squared and 3 squared equals 9. So you could just rewrite it using your perfect squares if you needed to. All right, so it says which solutions satisfy the zero product property here. All right, so if you have your factors and you know the zero product property is being applied, you have 2x plus 3 and 2x minus 3 equals 0. Zero product property says I can set each factor equal to 0 and solve. All right, so if I solve this one, I'm going to subtract 3 and divide by 2. So x equals negative 1.5. All right, this one I'm going to add 3 because negative 3 plus 3 cancels. 2x equals 3. Divide by 2. 3 halves is the same as 1.5. Now, we're talking about length, width, and height. All of those are a distance. So this one will not work because you can't have a negative length or a negative width. So the only answer that we could have, and I'm not able to circle it very good here with my pointer, but it would be x equals 1.5. All right, so it says what solutions satisfy the zero product property? So negative 1.5 and 1.5 both satisfy the zero product property. But in real life, the dimensions of the fish tank would be 4 by 1.5 and 1.5. Again, you're not going to have a negative distance. And since it shows that two of the dimensions are x, here's x and here's x, these are going to be the same distance there. So we know it's going to be 1.5 or 1.5 feet. All right, that is all for task 4. If you have questions, let me know. Lesson 17.4, task 5. All right, solve real-world quadratic equations. Projectile motion describes the height of a dropped or launched object as it free falls due to gravity. All right, so here's a description of some of the variables that you're going to see. All right, t is time since the object was dropped or launched in seconds. V sub 0 is the initial vertical velocity. It's going to be positive if it goes up and negative if it goes down in feet per second. And h sub 0 is the initial height of the object when it was dropped or launched in feet. and h of t is the height of the object from the ground t seconds after being dropped or launched, and that's in feet. All right, so it says the height of an object above the ground is modeled by h of t equals negative 16t squared plus v sub 0 times t plus h sub 0, when h equals 0 represents the ground level. So when the object is dropped, the model simplifies to h of t equals negative 16t squared plus h sub 0, because h sub 0 equals 0. All right, so let's look at the image here and see what we have. So it says, while standing at an outlook, Antonio sent a couple of pebbles to the canyon floor below. The illustrations show the two methods he used, and how long after Antonio releases them did each pebble fall before reaching the canyon floor. All right, so you can see here the first time he drops the pebble and it goes straight to the canyon floor. Here he launches it up and then it comes back down and goes to the canyon floor. So the first equation is going to be negative 16t squared plus 256. So you can see that he drops this to the canyon floor, and if you go back up here, it says initial height of an object when it's dropped. So that would be that right there, which is 256, which we've plugged in. So now if you factor this expression, you can factor out the greatest common factor of negative 16. Then you have a difference of squares that can be factored further. Using the zero product property, you can see t equals 4 and t equals negative 4. So time in seconds can't be negative. So we're going to say when it's dropped, it takes 4 seconds. All right, the second equation here, you can see that he launches it up 56 feet. So we go back up here, and the initial vertical velocity, positive if it's up. So that's going to be the 96 t in the middle, plus it's still going to drop 256 to the canyon floor. So again, we're going to factor this. This does not fit into a special factoring, so you're going to have to do what multiplies to give you negative 16 and adds to give you negative 6. So we've been working on this for a few days now, so hopefully you know that this is just factored form of this expression here. All right, so if you use the zero product property, t equals 8 or t equals negative 2. Again, negative 2 can't represent time in seconds, so it's going to be t equals 8. So if he drops the pebble to the canyon floor, it's going to take 4 seconds. If he launches it up and it comes back down, it's going to take 8 seconds. All right, A part says explain the reasoning. I feel like I just did that, so if you need to pause it or rewind it and listen again, just look at the tabs at the top where it tells you what each part of the equation represents. All right, B part says explain why the strategies for factoring these expressions are different. One was a difference of squares and one was not, so you had to factor them in 2 different ways. If you remember, over the past several lessons, we've learned lots of different ways to factor, so you just have to look at an expression and decide what works. All right, so the solution negative 4 and negative 2 are not valid solutions because t represents time and a negative time represents a time before the start time, and that's not gonna be a valid solution. So it says the dropped pebble reaches the canyon floor after 4 seconds, and the thrown pebble reaches the canyon floor after 8 seconds. All right, that's all for task 5. If you have any questions, let me know.